Leaving cert higher level, 2014, paper 2, question 4 is a sine graph or sine function. The graph below shows the voltage V in an electric circuit as a function of time t. The voltage is given by the formula V is equal to 311 sine 100 pi t, where V is in volts and t is in seconds. So you're given this graph, you're given 0.01 seconds here, so one full revolution from start to get back around to the start again. So one full revolution is in 0.02 seconds. So a tiny amount. And they show the second part of that graph as well. And they give you the scale on the diagram too. This was given as a grid as well. So you could see a lot of the numbers are a lot clearer than they would be here. Now, the range of the function. So we need to know sine max and sine min. All of you know the max you can get when you get sine is +1 and the min is -1. So you can see from my voltage here, 311 by -1 and 311 by +1. So minus 311 to plus 311 is the range of this function. Part A2, not part B, part A2. How many complete revolutions or periods are there in 1 second? Well, what do we say here? One full revolution is this 0.02. So we'd have to divide 1 full second by 0.02 to find out how many of them are in 1 full second. And 1 divided by 0.02 is going to be 50. So there are 50 in 1 full second. So if we multiplied 0.02 by 10, we'd get 0.2. So there's 10 and 0.2, and then multiply that by 5 to get up to your single second. So 50 overall. Part B of this question, you're given this incomplete table. And you're told the table below gives the voltage correct to the nearest whole number at equally spaced intervals from T1 to T12 over one complete period, as shown by the dashed lines on the diagram. Use the entries given in the table and the properties of the function to complete the table. So we're just given these first 3 values, but if you look up at the graph, we're given this value here, we're given this one, and we're given the max here at 311. Now this one here has to be the same as this one here, and this one that I'm going to has to be the same as the first one. And then similarly, we just have the negative versions of those going down. So you should be able to see here the pattern: 156, 269, 311. So the next one is going to be 269. Then we're back to 156. And they tell you T6 is 0.01, which you can see in the graph is 0. And then we're going negative 156. Negative 269, negative 311, negative 269, negative 156, and back up to 0. B part 2 of this question, really simple. If you've practiced using your calculator, a lot of people, you'd be amazed, don't practice enough with their calculator and get to an exam and they just can't do it. So standard deviation on a calculator, if you're using a Casio, shift setup will bring you into a list of things. One variance, we just need to type in one set of data here. We don't have 2 sets, so just one set. And then you type 156 equals 269 equals and so on till you get to the end. Then you press AC to clear off that screen. Then you press Shift 1 and that'll give you statistics mode. 4 is for variance. And when you go into 4, it gives 4 options. The third one you can see is sigma for standard deviation. And on my calculator, this is giving me 219. We need the whole number, 219.8. So I don't need any more. So 220 is my standard deviation for this question. Part C of this question. The reading of it takes longer than the maths, and this was typical of project maths in the early days. The standard deviation sigma of closely spaced values of any function of the form V is equal to A sine BT over one full period is given by K times sigma is equal to the V max. and where k is a constant and does not reply in a or b, and Vmax is the max value of the function. Use the function that we had above to find an approximate value for k. So k, if k sigma is equal to Vmax, then k is equal to Vmax divided by sigma, and we got Vmax to be 311, and above we got sigma to be 220, and 311 divided by 220, correct to, it's actually, sorry, 3 decimal places in this question, is 1.414. Part 2, use your answer in C part 1 or otherwise find the value of b required so that the function v is equal to a sine bt has 60 complete periods in 1 second and an approximate value for a. Here's my a, which is going to give me the max and min value of the function so that it has standard deviation of 110. Okay, we had 50 full periods in the previous one, so we look at our function. 311 sine 100 pi t. I think I wrote that down here too, didn't I? 311 sine 100 pi t. So that had 50 full periods. So 100 pi, this is my b value, my 100 pi. We initially had 100 pi over 2 pi gave me 50. So we don't know what 100 pi is in this case. So that's my b over 2 pi is going to give me 120. So b has to be equal to, sorry, 60 full revolutions, not 120. I'm thinking of the answer here. 60 complete revolutions. So b over 2 pi has to be 60. So b is 120 pi. So then we need the answer from the previous part to get an approximate value for a. So that's Vmax. A is equal to Vmax in this case. And we have k is 1.414. So Vmax, based on the formula up above, Vmax is equal to k times the standard deviation. And we have our 1.414. And we're told standard deviation is 110 here. So that'll give me a, which is Vmax. So a, dividing this up on a calculator, it's going to give me 155.5 for a. So we have a and b. That's the end of this question.